Okay, we're picking up where we left off in the previous video. Now let's learn about absolute value equations. An absolute value equation is just an equation to where at least one term has an absolute value with a variable expression inside of the absolute value. That's an absolute value equation. Just one term somewhere in the entire equation has an absolute value with a variable expression inside of it. Then you call that an absolute value equation. So, you know, if you had something like this with just this absolute value of x off to the side and then all kind of other stuff going on, okay, even though you just have just over here this one absolute value of x, still there's a variable expression inside of an absolute value. This is, you call this an absolute value equation. Okay, so, but like if you had something like this, well, no, there's no variable inside of this absolute value, so you don't call this an absolute value equation, because this, you could just simplify the absolute value of minus 7 and just turns, it easily just turns into, here in this case, a linear equation. Okay, so no, you need to have a variable inside of an absolute value. All right, so how do you solve absolute value equations? To solve any kind of absolute value equation, so let's look at an absolute value equation in one variable here. Okay, minus 3, let's do, is equal to, okay, the first thing you're going to do is just simplify the equation as much as possible. So let's add 7x to both sides. And so, yeah, there's nothing more we can do with this. So now what we're going to do is we're going to consider different scenarios. So any time in math, whether it be in algebra, calculus, wherever, anytime you see an absolute value expression in any situation, so an absolute value with a variable inside of it, that shouldn't scare you, because all it should signal to you is that I'm going to have to consider an either or scenario. It's like a this or that scenario, in the sense that we know how to simplify an absolute value depending on if we're above or below the 0 point for whatever the expression inside the absolute value is. So like if x cubed plus 8 is negative, if for any x value that would make x cubed plus 8 negative, well, we learned in pre-algebra that in that case we can simplify this by just doing this. We can remove the absolute value, because if whatever comes out of this is going to be negative, but we want to return its absolute value, we just multiply that by minus 1. And then if we know that we're in some region of x values where this is always going to be positive or zero, that's important to note, positive or 0, then we can simplify this by just doing this, right? Because what's coming out of here is always 0 or positive, so you don't need the absolute value. Okay, and so with that, what we're going to do is we're going to solve separate equations for all of the different scenarios with all of the absolute values in the entire equation. So if it was just one absolute value of an expression in the entire equation, we'd solve the equation for the case when the positive case and the negative case. Now, since we have two absolute values here, it's going to be more than just two scenarios, because we have to think about, okay, what about when they're both positive, or maybe when they're both negative, or when one is positive and one is negative. So there's going to be more scenarios in that case. But all we're going to be doing is solving separate equations and getting certain values. But the values we get aren't necessarily going to be solutions, but they'll have us very close to getting the solution. And I'll explain what I mean in a second. So now also let's just note that for absolute value equations, at the moment, we're just going to be thinking about these variables or placeholders for real numbers. We're not going to be thinking about complex numbers here. because the idea of, okay, what exactly is the absolute value of a complex number? Well, we can definitely extend that definition to complex numbers, but that's a little bit beyond the scope of algebra. We'll have to wait to get to the complex numbers course. But yes, absolutely, you can. Complex numbers are numbers, and once you're done with complex analysis, you'll be able to look at an equation like this and think about all potential solutions in the entire complex plane. But let's stick with absolute value equations. Let's stick with real numbers. So, okay, what you're going to do is you're going to draw a number line. And you're going to mark off all of the crossover points for all the absolute values, all the points where the expression inside the absolute value switches from positive to negative or negative to positive. Now, with polynomials, that's all we're going to work with in this course, just absolute values with polynomials inside of them. But with polynomials, all of the crossover points are going to be points where the polynomial equals 0. So we're just going to need to solve these polynomials, like solve for when all the real numbers where x cubed plus 8 is equal to 0. And in this case, there's just one, only -2 is an answer, but maybe with a bigger polynomial, there's multiple real numbers that make it 0. And so all of those would be marked off on this number line, all of the crossover points. So -2 is a crossover point. Let's see. -2 is a crossover point, and then 0 is a crossover point. And those are the only two crossover points. So we're done. Now, but like just to note, when it comes to other expressions, like you might have a rational expression like 5 divided by x. Well, when x is equal to 0, this isn't equal to 0, but that's still a crossover point, because you can see whenever you go from when x is less than 0, this is negative. When x is greater than 0, this is positive. So if we had this inside of an absolute value, x is equal to 0 would be a crossover point. And maybe I might put some examples where we have expressions other than polynomials inside of the absolute value. But if you're wondering, well, how do we figure out where all the crossover points are for any expression? Don't worry about that. That's something you're going to learn in depth in calculus. Once you're done with calculus, you could look at any expression, no matter what it is, and list out all of its points where it can switch signs. So that won't be a problem at all once you're done with calculus. Okay? So you list out all of the crossover points. Okay? And now what we have is we can draw these lines through the crossover points to see the different regions that we need to solve equations for. So, like, it's not like we're going to have to do when both of these are positive, when both of these are negative, when this is negative and this is positive, when this is negative and this is positive. Like, we're not going to have to do 4 separate equations. We can see from these boundaries here, we're going to have to solve 3 separate equations. So, okay, we start with, what we're going to do is, okay, let's look at x is less than -2. Okay, and notice how as we go through this, I'm going to account for like when x is equal to -2 or when x is equal to 0. Notice how I account for that, okay? So I'm just saying x is less than -2 right now, because when we if we're going to assume this is negative inside of here, then the way we simplify that is we remove the absolute value and put a negative out front. Well, we don't do this whenever x could be 0. We save the whenever x could be 0, that's the case where we don't include the negative out front. We just remove the absolute value. So for this case, for x is less than -2, that's going to cover when I put a negative sign in front of this, and that's also going to cover when I put a negative sign in front of this. Because okay, no, actually, if x is less than or equal to -2, this is going to be negative. So I was talking about this. When x is less than -2, you simplify this by removing the absolute values and putting a negative sign. But when x is equal to -2, you don't put that negative sign. You just remove the absolute values. So when x is less than -2, this accounts for the scenario where we remove both absolute values and put negative signs out front. So now we have this equation here where we removed both absolute values and put a negative sign out front. So let's solve this. Minus x plus 9x is 8x. Okay. Add x cubed to both sides. Subtract 8 from both sides. Okay, so now let me just go ahead and throw this into the calculator here. So solve x cubed plus 8x minus 11 is equal to 0 for x. So 1.17 is the only real number solution to this. So, okay, so x is equal to 1.17. Okay, but now the next thing we want to do is make sure that this value is within the interval that we were restricted to. Is 1.17 less than -2? No, it's not. So no, this is not a solution. Because why not? Because the way that we simplified the absolute values was based on x being less than -2. So it makes no sense to say that x is equal to 1.17 in that case. So there's no solution here. When x is less than -2, there's no solutions. Okay, now next we're going to do in this region here. And we're going to say that, so here x is less than 0 and greater than or equal to -2. I'm saying greater than or equal to because, okay, if x is less than 0, that means we're going to have a negative sign out front of this. Okay, but we want to do another scenario here. We don't want to put a negative sign in front of this again. We just solved that equation. We want to do, in this case, we're just going to remove, this could be 0. Or no, this could be -2. If this is -2, then this is 0, and so that we just remove the absolute value. So, or no, wait, what? Let's see. Plus 2x. Oh wait, I had that right. So okay. Okay, so minus x plus 9x is 8x. Okay, let's subtract 8x from both sides and add 3 to both sides. Okay, now let's plug this in here. So x cubed minus 15x plus 3. Okay, so we've got these 3 separate solutions here, but which one of these, they need to be between -2 and 0. So these outer 2 are not, it's only this one in the middle. So x is equal to 0.20. So, okay, x is equal to 0.20. Well, let me put it, let me erase this. Okay, that's a solution. Okay, but now we have one more region to check. That's if x is greater than or equal to 0. Because now we're going to do the case where both of these are positive. So we just remove the absolute value on both of these. So 3x minus 3. So x cubed, let's subtract 3x from both sides. You get minus 10x. Let's add 3 to both sides. Okay, so you've got x cubed minus 10x plus 11. Okay, now which one of those are greater than or equal to 0? You've got 2, 1.34 and 2.3. So, okay. And now that's it. Those are the 3 solutions. And wait, no, okay, this solution here was outside of, was not between 0 and -2. So no, this is not a solution. I messed that up. Okay, that was not a solution. Just these 2, right? We got that. We got 0.2 when analyzing this interval. That's not between 0 and -2. 0.2 is not. So these are the two solutions. Okay. And so that's the idea. Now, so the textbook gives these properties here of absolute value equations, but these are really simple cases, and it's only these simple cases that the back of the book, or not the back of the book, but the back of the section gives example problems based on these simple cases. But I think I'm going to do an extra video with some more difficult absolute value equations. But let's go through each of these properties here, and we can see, based on what I just described to you, we can see where all of these come from. So it says that if you have the absolute value of some expression, variable expression, is equal to, this is a positive real number, then the solutions to this are that the expression is equal to k, or the expression is equal to minus k. Where does this come from? Well, okay, the idea is you take, we have this one absolute value in this entire equation here. This is really simple. You find all of the x values that make this, where this could cross over signs, and then you're just analyzing. So let's just think about how, okay, this was, let's say this crossed over here. It's negative over here, positive over here. Well, for the negative region, you say that you do this, right? Well, what is that? That's u is equal to minus k. And then the positive region is or positive or equal to u, where this could be positive or 0. You just remove the absolute value. That's u is equal to k. And so that's what it says here. That's equivalent to u is equal to k, or u is equal to minus k. Okay, but now you might ask, well, but what about they don't include needing to check to see if the answer you got is within the interval that you're analyzing. Well, they call that in the textbook extraneous solutions. They just say that, look, you're going to solve it this way, and then once you get a solution, you need to go check your solution in the original equation. And if it doesn't check out, you don't include it. Well, for the general method, we don't have extraneous solutions. That's where the extraneous solutions are coming from. It's the fact that you got an answer and it wasn't in that interval. And so what that means is if you plug it back into the original equation, it's not going to be a solution. That's what that means. Or maybe it is, but then if it is, you would have found it anyway when you went analyze that region that it was actually in. Okay. Now, what about this second property here? The absolute value of some expression is equal to 0 means that u is equal to, that expression is equal to 0. Well, this just makes intuitive sense. I mean, this is something we can use this to analyze any kind of scenario with absolute values and equations. If you've got the absolute value of some expression on one side and it's equal to 0 on the other side, well, there's only one scenario there that could possibly solve this equation. The expression needs to equal 0. Has to. Anything else is not going to be a solution. So that makes intuitive sense. Now, what about this? This is pretty useful to think about just for our intuition of absolute value equations. What would be the solution to this? If k is positive, so that means that this is a negative constant over here. Well, there is no solution. There's no value, no matter what you plug in here. No matter what you plug in here, no matter what comes out of it, when you take its absolute value, it's going to be greater than or equal to 0 no matter what. So there's no solution here. Okay, now what about this last property here? It says if you have the absolute value of u, some expression, is equal to the absolute value of another expression, variable expression, then the solutions are going to be you need to solve u is equal to w, or u is equal to minus w. Where is this coming from? Well, okay, if we drew a number line here and we thought about, there's these two crossover points where u crosses over from positive to negative or negative to positive, and same thing with w somewhere. Then, okay, we've got, let's start over here. So if u is positive or 0 and w is positive, then you want to solve u is equal to w, okay? Now in this region, u is negative and w is positive or 0, so in that case we want to do minus u is equal to w. Okay, now here both both w and u are negative, and so in that case you get minus u is equal to minus w. But because of the symmetry, we have the same equation, right? You multiply both sides by -1, you get u is equal to w. And even in this case, if we multiply this by -1, you get u is equal to minus w. It wouldn't matter which one we chose to be the minus or the plus. In general, it does matter. In general, when both are positive and both are negative, it's not going to have that symmetry, and so you're going to have to solve those equations separately. And same idea here. If w is positive, u is negative, or u is positive, w is negative, in general, that's going to be two separate equations. It's just because of this symmetry here, where you just have this one absolute value on one side and one absolute value on the other side, it works out this way, where you just have to solve two equations. However, you want to be careful here, because you don't want to fall into the trap of thinking that, okay, I solved for the u is equal to w case, got a solution, solved that solution, was in the range, crossed it out or boxed it in, and then moved on to the next and then moved on to the next area. And then when you get to this last region, minus u is equal to minus w, you say, oh, well, I already solved this, so I don't have to do this. Yeah, you don't have to solve the equation again, but you do need to go look at the solution and see, okay, well, is that solution that you might have crossed off before might be in this range, right? It's a different, it's the same equation, but it's a different range. You need to make sure you account for every single value for all real numbers. Like, you need to check this. You need to solve the equations, but if you don't have to solve the equation twice, you don't have to. But you need to, for every single x value or variable value on the entire real number line, you need to be checking. You need to be checking it. What is the corresponding equation? What are the solutions to that equation? Is that within the range? That's why I was kind of hinting how it was important to note that when you're saying which, are you greater than or equal to x? Are you less than or equal to x? Because you need to be accounting for every single value. So you know, okay, I'm greater than or equal to this x value, so I've accounted for all of these x values. Now I need to check all of these x values and then all of these x values. So you need to be careful with that. So let's work some examples, and these are going to be simple examples, but let's apply those general principles to analyze how exactly we're going about solving these. So, okay. We've got this first problem, 2 times the absolute value of 3 minus 2t is equal to 6. So first step is we just simplify as much as possible, as much as we can. Divide both sides by 2. Now we can't go any further, so now we start looking at the different scenarios. So we only have one absolute value here. So there's only going to be, well, with a linear expression inside, there's only going to be one crossover point, but if there was there could be other kinds of expressions with different, you just set this equal to 0 and find the different values where it changes sign. There could be multiple, if this was a polynomial, there could be 3 or 4 crossover points, right? So, okay, the crossover point's going to be, we see is going to be 3/2. So we've got these two separate regions here. So, okay, let's start from the right here. So, okay, if we're greater than or equal to 3/2, so t is greater than or equal to 3/2. It's important to include equal, because if we're just going to remove the absolute value, we can do that when t is greater than or equal to that crossover point. Or this can be 0 in that case. So, okay. Because we want to account for all real numbers, right? As we do this. So, okay. Now let's solve this. We can, since we know t is greater than or equal to 3/2, we can simplify this absolute value, remove it. Okay, subtract 3 from both sides, divide both sides by -2. We've got t is equal to 0. Now, is that in the, okay, wait, no, I think I messed this up. Yeah, okay, wait, yeah, this is, I'm sorry, hold on. This is when, okay, if t is just greater than 3/2, then what's inside here is going to be negative. Because like 3/2 times 2 is 3, 3 minus 3 is 0. Anything greater than 3/2 is going to be negative. So we're not including equal to 3 halves because we're not going to include the 0 case, because if this is going to be negative inside this absolute value, then we can simplify that this way. Okay, so now let's solve this. Add 3 to both sides. Divide both sides by 2. You get t is equal to 3. So is this within the interval? Yes, it is. So, okay, that's a solution. Okay, now let's see. Next would be t is less than or equal to 3 halves. This includes when this expression is equal to 0, or any positive number, because in that case, we just remove the absolute value. Now subtract 3 from both sides. Divide both sides by -2. T is equal to 0. Is that within this interval? Yes, it is. So those are the two solutions. Okay, let's do another problem. Okay, let's flip this and subtract 8 from both sides. And we see here where there's no solution, right? We can see this clearly, there's no solution. But just to point out, like for a more complicated equation, if you couldn't see if there's no solution clearly, then if we could go through the process here, we'll see there's no solution. So the crossover point would be at 3/7. So, okay, here are the two regions. So when we're, or no, 7, is that right? Yeah, 3/7. And then, so if we're greater than or equal to 3/7, it's going to be positive. So 7w minus 3 is equal to -6. 7w is equal to -6 plus 3 is -3. W is equal to -3/7. But we are not in this interval, so that's not a solution. Okay. Now, what about w is less than 3/7? So we simplify that like this. So -7w plus 3. Okay. Subtract 3 from both sides. Okay. Is that less than 3/7? No. So that's not a solution. So you see there's no solution. But we could have seen that here from the original equation. It was simple enough to where we could see that was the case. Okay, now let's work these last two problems here. And in these cases, we've got the one absolute value expression on one side and one absolute value expression on the other side. So yeah, this has like that symmetry involved to where you don't have to actually end up solving. Typically, if you had two absolute values with different expressions inside, you're going to have to solve 3 separate equations. But because of the symmetry here, you only have to solve 2. But you have to be careful with that. So, okay, the crossover points here we can see are going to be -1 and 5 halves. So typically that would mean there's 3 separate regions. But, well, there is, well, I take it back. That does mean there are 3 separate regions, 100%. You need to check all regions. But this typically would mean there's 3 separate equations you have to solve. That's going to end up not being the case just because of the symmetry here. So, okay, if x is, let's see, we want to do greater than or equal to 5 halves. And this is why it's important to note when you're saying greater than or equal or when you're just saying less than, because we simplify absolute values. If they're positive or 0, we just remove the absolute value. And it's important to note if you're saying equal to 0 or not, because we need to be checking every x value. So, okay, if x is greater than or equal to 5 halves, then this is going to be positive or 0, so we just remove the absolute value. So here we're doing x is greater than or equal to 5 halves. And then this is always going to be positive. So, okay, let's subtract x from both sides. Now let's add 5 to both sides. Okay, is 6 greater than or equal to 5 halves? Yes, it is. So 6 is a solution. All right. Now, so that was this region. Now let's do this region here, minus 1 to 5 halves. So x is, let's just do less than 5 halves. So this is always going to be negative. And then greater than or equal to negative 1, this will be positive or 0. So we've got minus, okay, so minus 2x plus 5 is equal to x plus 1. Adding 2x to both sides, subtracting 1 from both sides, dividing both sides by 3, x is equal to 4/3. So is that in between here? Yes, it is. So x is equal to 4/3 is going to be a solution. Okay, so I mean, I don't need to put these intervals. These don't mean anything in regards to the solutions. Okay, so x is equal to 4/3 is a solution. So now don't fall into the trap of saying, okay, well, I'm done, because when I come over here, what's going to happen? When x is less than negative 1, they're both going to be negative. But when I do that, well, I can just multiply both sides by negative 1. And I've already solved this equation. Yes, you don't have to solve the equation again. I erased that equation, but you don't have to solve the equation again. What was it? That was both are positive. It was x is equal to 6. Okay, you could just come to the answer you got. But if, let's say we cross this off as a solution for the first analysis, or you could think about, what if we did the negative region first? Well, x is equal to 6. That's less than negative 1. That's not less than negative 1, so that's not a solution. And then we just skipped the positive region. We would have lost a solution. So all it means, the symmetry just means you didn't have to solve the equation again, but you still need to analyze the solution. So now we've analyzed all regions, including the boundary points, right? We also analyzed the boundary points. So that's it. That's the two solutions. Okay, let's see. We've got absolute value of 6 minus x is equal to absolute value of x minus 6. Okay, there's only one boundary point here. That's at x is equal to 6. Okay, so if we're greater than 6 or equal to 6, then both would be 0 if we're greater than or equal to 6. So like for here, the general practice is you only simplify. You don't want to be simplifying an absolute value with a negative out front. Only when it's negative, you want to do that. But I guess if you could do negative or equal to 0, you could do that. But just to show you that like, okay, in this case, if we try to say x is greater than or equal to 6, if we try to do this, well then, okay, this would always be positive or 0. That makes sense. But then this would be negative or 0. And so typically we don't simplify an absolute value if it's equal to 0 but you could. But we don't have to. We could just do this. We could just say, okay, since it's kind of confusing, let's just say x is greater than 6. Okay, in that case, then this is going to be negative. And this is going to be always positive. So we just remove, even though it's not going to be 0, that's fine. We just remove the absolute value. So minus 6 plus x is equal to x minus 6. Subtract x from both sides. Okay, this is an identity, but this just means that all of these are solutions. All x greater than 6 are solutions, right? Okay. Now we can do the same thing with x is less than 6. So we've accounted for everything greater than 6. Now everything less than 6. In that case, we're going to get what? This is going to be positive. And this is always going to be negative. Okay, so we've got, I mean, this is the same equation as what we just solved. It's because we can multiply both sides by negative 1 because of the symmetry. So this is going to be all real numbers. So everything less than 6 is a solution. Okay, but we're not done. We haven't analyzed what about when x is equal to 6. Well, how do we do that? Well, we can just plug it in. If it's just a number, one number, just plug it in. 6 minus 6 is 0. 6 minus 6 is 0. Absolute value of 0 is 0. Absolute value of 0 is 0. 6 is a solution. So the solution is all real numbers here.